Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. All right, y'all. Today we're going to start introducing equations. We've been working with equations for many years now, but sometimes the concept just doesn't come through. So hopefully today, I'm going to start from the beginning, and hopefully we can demystify equations starting today. So first of all, an equation is an expression with an equal sign, okay? So whenever you see numbers, variables, operation signs, and an equal sign, you know that's an equation. The equation is stating that the expressions on either side of the equation are equal. So when you have an equation like 2x plus 3 equals 5x minus 7, you don't particularly know the value of x yet. That's the whole point of solving it. But what this is stating is that the left side of the equation, 2x plus 3, is equal to the right side of the equation, 5x minus 7. And then is the goal of the person who is solving this equation to find the value of x. Hence, the goal of any equation is to solve for the value of the variable or variables in question. Sometimes there's two variables you have to solve for. Sometimes there's three. It depends. Okay? And these solutions make the equation true. The solution or solutions to any equation is or are the values of the variable which make the equation true. Okay? Solutions are said to satisfy the equation. Satisfy means when you plug it in, it makes the equation true. Okay? So that's what an equation is. Really, really try to understand what the concept is behind it. Now, let's talk about solutions. Sometimes they're going to give you choices for solutions of a given variable in an equation, and they want you to determine whether or not those are solutions. So this is very simple. Let's go back to what the meaning of an equation is. An equation is stating that both sides, okay, both the expressions on both sides are equal. So in this particular equation, what they're stating is that x squared minus 5 is equal to 4x plus 7. The goal here is to find the x value which satisfies this equation, or in other words, the goal is to find the value of x that makes this equation true. So in this case, we don't have to solve it. We're just going to plug in these two choices and see which one works. So let's first try A. All right. And for choice A, they're telling you that x equals -2. They want to know whether or not this is a solution. So let's plug it in. First of all, the value of x is -2. So please be careful when you are evaluating. Remember, we've talked about this before. Make sure that you place the value of the variable being raised to any power within parentheses, and then you square it. Now you may say, why is that important? Well, let's think about it. If I don't do this, I'm going to write down -2 squared. And if I do this properly, this equals -4, because the exponent of 2 only affects the base immediately to the left of it. And that would be wrong for this particular example, because the value of x is being squared. So hence, you have to put the value of x inside of parentheses. So you have -2 squared minus 5 equals 4 times x, which we're testing out -2 this time, so we evaluate it with -2, plus 7. So I'm going to have -2 squared is 4, minus 5 equals 4 times -2 is 8, plus 7. 4 minus 5 is -1, and -8 minus plus 7 is -1. So yes, that is a true statement. -1 does equal -1. So that means that absolutely this is a solution. So when x equals -2, this makes the equation true. So -2 satisfies the equation. Let's try B. This time, we're trying to see whether or not x equals 2 is a solution. Well, we're going to plug it in. So this time we have x, which is 2, being squared, minus 5 equals 4 times 2 plus 7. So I have 2 squared is 4 minus 5 equals 4 times 2 is 8 plus 7. 4 minus 5 is negative 1. 8 plus 7 is 15. And no, those do not equal each other. So when x is equal to 2, that is not a solution. It does not satisfy the equation. And there you go. All right, so whenever they want you to test whether or not a variable is a solution, once again, just plug it in and make sure that it satisfies the equation. It makes the equation true. Okay, so let's talk a little bit about properties of equality, okay? When solving equations, it is important to understand that whatever operation is performed on one side of the equation must be performed on the other side of the equation. Doing this maintains the equality or the balance of the equation. Think about an equation kind of like bench pressing, okay? When you're bench pressing, think about this, picture this. Do you have 100 pounds on the left side of the bar? And do you have 50 pounds on the right side of the bar? You're hopefully thinking, no, that's not the right way to do it. Of course not, because it's not in balance, okay? When you're bench pressing, however much weight is on the left side of the bar must be the same weight on the right side of the bar in order for you to get an even and balanced workout. Well, it's the same thing here with an equation. Whatever I do to one side of the equation must be done to the other side of the equation, just like lifting weights. If I add 10 pounds to the left side, then I have to add 10 pounds to the right side of the bar. If I take away 15 pounds from the left side, then I have to take away 15 pounds from the right side of my bench press bar. Okay, so just think of that. Now, let's talk about some properties. First of all, whenever we're giving an equation, we're going to want to simplify either side. And this is a property of equations. This is basically saying, hey, you're allowed to do this. Okay? It's the process of removing grouping symbols. Please remember the distributive property, okay? And combining like terms on either side of the equation. So whenever you see an equation, you are allowed to simplify before you start solving, before you start moving things around from one side of the equation to the other. So in this particular example, I have an original equation here of 2 times parentheses 3x minus 5 close parentheses plus x equals 12. Well, I'm going to use the distributive property. Oh, sorry about that. I'm going to use the distributive property. Wow. Sorry about that, guys. My board is not cooperating with me. All right, let's try this one more time. Okay, so I'm going to distribute that to, sorry about that, guys, to both sides. I mean, to everything inside of the parentheses. And I have 6x minus 10 plus x equals 12. Okay, I just simply applied the distributive property. Now I'm going to add like terms on both sides. 6x's plus 1x is 7x's minus 10 equals 12. Now I'm not going to go ahead and continue to solve. I just wanted to illustrate the property of being able to simplify either side. So now I'm left with this equation right here, 7x minus 10 equals 12. And from there I can start solving, okay? So that's the first property of equations. Another great property is the addition property of equality. This again is a mathematically legal process. It's the process of adding or subtracting the same quantity to or from each side of the equation. Now, you may be asking yourself, why would it be called the addition property of equality if you can also subtract? Well, think about it. When you're really subtracting, aren't you really just adding a negative? For example, when I have 2 minus 5, doesn't this really read 2 plus a negative 5? Okay? Hopefully you're all in agreement there, because that is what's happening. So you're really always adding numbers. It's just a matter of whether or not you're adding positive or negative numbers. So that is why it's called the addition property of equality. All right, so let's get to it. So I have x minus 11 equals 8. Well, in order for me to get the x alone, I'm going to add 11 to both sides because the inverse of negative 11 is positive 11. We learned that already with the additive inverse property, right? Any number plus its opposite equals 0. So I'm going to go ahead and add 11 to both sides. And this is x equals 19. And that is a perfect illustration of the addition property. So in this one, this is just a one-step equation. I already solved it. There's nothing else left to do. Okay. Next, you can apply the multiplication property of equality. Similar to the addition property, this is the process of multiplying or, oh, my bad, guys. Sorry about that. Or dividing. Go ahead and change that, please, in your notes. My bad, I apologize. Process of multiplying or dividing the same quantity to or from each side of the equation. Again, you may say, wait. If it's the multiplication property of equality, why are we dividing? Well, it's kind of the same thing. If I have, let's say, 21 divided by 7, can't I really break this up into 21 over 1 times 1 over 7? Okay, do you see how that just worked there? Hopefully you do. And that's why I can divide or multiply to and from both sides under the multiplication property of equality. Because you may be multiplying a whole number or you may be multiplying a fraction. Okay, when you multiply a fraction, it's the same thing as division. Again, for example, let's say I have 12 times 1/4. Isn't that 12 over 4, which is 3? So try to really focus on that, write that down, make sure you understand that because it's a very powerful property. Okay, so my original equation is 12x. I'm going to go ahead and use the multiplication property of equality and divide by 12 to both sides, where x equals 4. And I was able to divide 12 to both sides because of the multiplication property of equality, and it leaves me with an equivalent equation of x equals 4. Let's say I have x over 3 equals 2. Well, in this case, I have x being divided by 3, so I cancel division with multiplication, so I'm going to multiply 3 to both sides, and x would equal 6. That's also legal using the multiplication property of equality. Okay, let's continue. Another property that we're going to discuss today is the ability to interchange both sides of the equation. It's the process of simply using symmetry to rewrite the equation. Okay, so this one's real easy. If I have 12 equals y, I can go ahead and say that y equals 12. I can literally take what's on one side of the equation and just flip it with the other side of the equation. But please remember, all the signs have to stay the same. So, for example, if I have negative 13 equals y, that will equal y equals negative 13. Please do not keep the negative with the y there. Keep it with the 13. All right. Now, let's go ahead and solve these, and let's identify the property of equality used to solve each equation. I'm going to solve them for you right now. Most of these you can probably solve on your own as well. I know that you've been exposed to single-step and two-step equations, but I promise you we will have a whole lecture series on equations in Chapter 3. But for right now, I just want to focus on the properties. So here for A, I have x plus 2 equals x plus 8 equals 2. So I'm going to subtract 8 to both sides, and x will equal negative 6. And the property that I used here was the addition property of equality. Why? Because I subtracted 8 to both sides, so I added a negative 8 to both sides because of the addition property of equality. For B, I have x over 4 equals negative 3. So in this case, I'm going to multiply 4 to both sides of the equation. The 4's cancel. X equals negative 12. And this process was allowed because of the multiplication property of equality. Okay? Then I have 3x plus 4 equals negative 11. Again, Don't worry about how or why I'm doing what I'm doing. I promise you we're going to learn about this, but this is a two-step equation. And in a two-step equation, we always undo addition and subtraction first. So I'm going to subtract 4 to both sides. So I'm left with 3x equals negative 15. That first step was allowed because of the addition property of equality. Okay? And then I have 3x equals negative 15. So I'm going to go ahead and, sorry about that. So I'm going to go ahead and divide 3 to both sides. So x will equal negative 5. And the property that allowed me to divide 3 to both sides was the multiplication property of equality. Okay? And there you go. All right, for D, actually, let's go ahead. Yeah, let's do D, and then I'll give you another one on top of that. In this case, I have 6x minus 8 equals 4, so I'm going to add 8 to both sides, giving me 6x equals 12. I was allowed to add 8 to both sides because of the addition property of equality. And then, all right, come on, class, tell me. I have 6x equals 12. So what am I going to do to both sides? All right, hopefully you said divide by 6. All right, and x will equal 2. Now, what property allowed me to divide by 6, y'all? Come on, I know you know it. What is it? Good. It is the multiplication property of equality. Awesome. All right. All right, hopefully you got this. All right, how about a little bit of word problem action here? All right. Simon earns $53,680 per year. Write and solve an equation in order to find his weekly pay. All right, again, we're going to train you, I promise you, on word problems and equations and the whole 9 yards. But right now, let's just use a little bit of logic and let's see if we can figure this out. Simon earns $53,680 per year, okay? Write and solve an equation in order to find his weekly pay. Okay, well, here's the clue right here, weekly. There are 52 weeks in 1 year, okay? And in 1 year, he makes $53,680. So he gets paid weekly, so there's 52 payments of X dollars every year that give him a total of $53,680. All right, think about that. Don't just copy it down without thinking about it. Label everything, please. Look how I label things. I want to make things easy for myself. So once you have this written down, now it's easy. I'm going to go ahead and divide by 52 to both sides. And my X, which is my weekly payment, is 53,680 divided by 52. So that would be $1,032.31 per week. Okay? So X equals the weekly pay. All right? Easy peasy. All right, next. Tickets for a concert cost $115 for each floor seat and $75 for each stadium seat. The 1,800 available floor seats have been sold out. The total revenue ticket sales was $469,500. Write and solve an equation in order to find out how many of the stadium seats were sold. Okay. Let's first label. Okay. We've got floor seats, which I'm going to call F. And the floor seats were $115 each ticket. Okay. And then we have the stadium seats, which I'm going to call S. And those are each $75 each. And there's 1,800 available floor seats. And we don't know how many stadium seats there were, but we do know how much they made in total. So we have 1,800 floor seats times $115 for each one of those. Plus, okay, we have $75 for each stadium seat S, which is going to equal $469,000, $469,500. Okay, so take a look at this, guys. Please don't just write it down. Think about this. Okay, 1,800 floor seats times $115 each floor seat. Bam. And then it's $75 for each stadium seat, but we don't know how many stadium seats were sold. So hence we have $75 times S, the number of floor seats. So I want to go ahead and find out what this is. So let's go ahead and simplify first using the properties of equations. Let's simplify both sides. So the first thing I'm going to do is multiply 1,800 times 115, which equals 207,000, plus 75 times S is 75S, and that equals $469,500. Now, I'm not asking for it, but just in case an SAT does ask you for it, let me move this out of the way here real quick for you guys. So I want to show you. It's always good to really understand everything that you're doing. You were able to perform this part right here because you can simplify both sides of an equation. Bam. That's why you were able to do that, okay? In short, you could just say simplify. That is totally legal. In fact, that's probably how you're going to see it on SATs and ACTs. That first step was as easy as just saying simplify, because you're allowed to simplify both sides of the equation before you start solving. Okay, now we're going to undo addition and subtraction first, so I'm going to subtract 207,000 to both sides. And I'm going to be left with 75S equals 469,500 minus 207,000. Okay, so we got 0, 0, 5, 2, 6, and 2. Okay, so 262,500 divided by 75. So S will equal, divided by 75 equals 3,500. So S equals 3,500 stadium seats were sold. Cool? All right. Hopefully that made sense. Oh, and real quick, sorry about that. What property allowed me to complete this step right here, to divide 75 to both sides? You got it. That was the multiplication property of equality. And just for giggles, what property allowed me to subtract 207,000 to both sides? That was, of course, the addition property of equality. Okay? All right. Well, on a road trip, you stop for lunch after 5 hours on the road. After a 1-hour lunch, you realize that you only have 85 miles left to go out of the 435-mile trip. Let me reread that again. After a 1-hour lunch, you realize that you only have 85 miles left to go out of the 435-mile trip. Write and solve an equation in order to find your average speed during the first 5 hours of the trip. Okay, and this one you have to read carefully. Okay? So I'm going to give you a second to read it again on your own. Really try to digest it. Okay, so let's first of all find out what we're solving for. Write and solve an equation in order to find your average speed. Okay, so we're looking for my average speed. Okay, and average speed, we can call it A for average speed, S for speed, or me, I like to just go ahead and call it R for rate. Okay, so R equals my average speed, but you can really use any variable you like. Okay, it really is up to you. But that's what we're looking for, my average speed. Now, little note here. Let's remember that distance equals rate times time. Okay, distance equals rate times time. Let's see what they gave us. They gave us time. They want to find the average speed during the first 5 hours. So my time here is 5, right? T is for time, and in this case, time equals 5. My rate we don't know, so that's R, and that's going to equal my distance. Now, before you all say 435, no, that's wrong. Remember, after 5 hours, he has 85 miles left. So how far did he really go in those first 5 hours? Well, 435 miles minus 85 miles left to go. That means that he traveled 350 miles in those first 5 hours. So my distance is 350. Okay? Now I want to solve for R. So I'm going to divide 5 to both sides, and R equals 70 miles per hour. And I was able to divide both sides by 5 because of the multiplication property of equality. All right? And there you have it. Thank you so very much. I hope you learned a lot, and have a great day. Take care now. Bye-bye.